For today's question, we will answer this geometry challenge, and here's the question. So given this right triangle with the legs 3 and 4 units, now inside of this right triangle, let's draw a semicircle. And now, the question is, what is the length of this segment, X? Now pause this video right now and see if you can answer this question, because I will show you the solution in 3, 2, 1. So given this right triangle and inside of it we have a semicircle, then the goal is to find the length of this segment, X. Now to answer this kind of question, we need to find first the important points. The first point is the center of this semicircle. Now also, important points are the point of intersection, the point of tangency of the semicircle to the legs of this right triangle. Now, what we're going to do is to draw the radius of this semicircle. And take note, since this point is the point of tangency, we know the radius is perpendicular to this tangent line. Now, let's call the radius of this semicircle be equal to r. Now, we created a square with a side length of r. We know this is also r. And since we know this length equal to 4, this is r, so the remaining length must be equal to 4 minus r. Alright, now we will do the same thing in this side. We know the length equals 3. We know this side is r, so the other side, or this remaining segment, must be equal to 3 minus r. Now from here, we can see similar triangles, because if we let this angle be equal to alpha, this also alpha, corresponding angles are congruent. This angle beta, this also equal to beta, again corresponding angles are congruent. Now these two small right triangles are similar to each other, so we can say that 4 minus r over r equals r over 3 minus r. Now we can now solve for the value of r. So first, let's cross multiply. So we have 4 minus r multiplied by 3 minus r equals r squared. If we simplify or multiply 4 minus r to 3 minus r, we get something like 12 minus 7r plus r squared. Then subtract r squared on both sides. R squared is gone. This is just 0. So we have 12 minus 7r equals 0. Now, we can solve for the value of r. Subtract 12 on both sides. Then divide both sides by negative 7. So we get that r equals 12 over 7. Now we know the value of r, or the radius of this semicircle. But the question here is to find the value of x, not the radius of the semicircle. So now, let's focus on this small right triangle. And we know that this part is the radius of this semicircle. Now at this point, we now know the hypotenuse of this small right triangle. And then, since this small right triangle is similar to the big right triangle, we can now find also the hypotenuse of this right triangle, because this is simply equivalent to special right triangle 3, 4, 5. Now, using their similarity, we can now set some ratio. So we have here r plus x, which is the hypotenuse, over one of its leg. So r plus x over r equals the hypotenuse of the big right triangle be equal to 5 all over 4. Now, let's focus on this equation and let's simplify. Cross multiply will give us 4r plus 4x equals 5r. Now, subtract 4r on both sides, we get that 4x equals r. Now, we know that 4 times x equals the radius of this semicircle. Now, we know the radius. The radius is 12 over 7. And now, divide both sides by 4 to get the value of x. Now, we know 12 is simply 4 times 3. So, we can cancel out 4 on the numerator and 4 on the denominator. This simplifies to 3 over 7. Therefore, given this figure, then the value of this x, or the segment x, simply equal to 3 over 7. And that is our answer to this question. Therefore, given this figure, then the numerical value or the length of the segment x is equal to 3/7 units. And as always, we are done.